Hey everybody. Today what we're going to deal with, you can see the title up at the top, are squares and square roots. So what we're going to do is go through a full review of squares, square roots, all of which I would hope you've seen in the past, but I'm going to make the assumption you have not. Or I'm even going to make the assumption at times that maybe the way we remember some of that theory with squares and square roots may be incorrect. And so we're going to also use this as an opportunity to review some material, maybe introduce it, and perhaps introduce it in a way that gives us just a broader meaning to those two operations. So what I want you to make a note of first is what's on the slide that you see. We're going to start with that green question of what is 5 squared? Now, I'm not asking that question because I don't think you know the answer to that. It's really just to start things off today. So jot down a quick answer to what is 5 squared. We'll make sure that we match up. I'm hoping that you have 25. And then we can jump into a formal statement of what a square is. So make sure in your notes that you get down what I see in red, that a square is the product of a number multiplied by itself. Now, there are times where you can see that definition without the word multiplied in there, because you all know what a product is. Product is the answer we get when we multiply. And so sometimes you'll see a square stated as it's the product of a number and itself. Okay, I'm hoping that that came back to us, and pretty quickly as you jot down that blue line, you could fill in the blue blank. Therefore, the square of 5 is. And notice we've got the same thing as what we addressed in green. Okay, I'm hoping we're good with the term square. Quick little part for us though, like in purple, you see the question, where does a square come from? Okay, we should notice that each time we've used the term square, what we've really been addressing is an exponent 2. So why do we call an exponent 2 squared? Well, to do that, let's jump back and deal with a little bit of geometry. So if I was to go through and deal with some measurements that I hope are good, that let's say that I had this shape that you see in front of you, and this dimension was the same as this dimension, the same, and so on. And I said that this dimension was 5 centimeters. I hope we're good at the difference between a linear unit and a squared unit. Like if I asked you, well, what is the area of that shape? I would hope most people would say something along the lines of, well, I know to calculate the area of a box, it's just length times width. And so it's 5 times 5. Maybe we even wrote down that it was 5 squared, since all of those dimensions were the same, and you would have come in on a 25. Now, I would ask you, of course, 25 what? Because that answer is incomplete. And if you told me centimeters, we would be incorrect. That I hope we are good at the difference between a linear unit and a squared unit. So that being, if I was to say that that dimension right there, if I follow that green arrow, so now I just get rid of the arrow to make it an ending, a line segment, that might be 5 centimeters. Let's just call it that. Well, if that was 5 centimeters, then 5 centimeters by 5 centimeters would represent a square unit. So if I simply got rid of the 5s in this problem, and I said, okay, well, let's call that green 1 centimeter. Then that length may represent 1 centimeter. Well, a 1 centimeter by 1 centimeter unit would then represent that shaded in portion. And that's what we have in that yellow box. If it is 5 centimeters by 5 centimeters, then it would take 25 1 centimeter by 1 centimeter boxes to fill that thing up. What shape did I just create that's shaded in? A square. That's why they're called squared units. So when we use that term square, from a geometry standpoint, we're producing the shape of a square by multiplying a unit by itself. Okay, maybe that just gave us some broader context to some stuff. I want to jump in and play around with some squares a little bit. Okay, now, what you see sitting in front of you, I've put on whiteboard at top. You can be doing this on your whiteboard. You could be doing this in your notes. I don't really care. But what I would like you to do is list out all the perfect squares that you know without using a calculator. So I actually want you to take that red list that we have, 1, 4, 9, and so on and so on. You see the ... And keep writing out that list of all the perfect squares you know until you can't do any more. I'm not talking about pushing buttons in a calculator. Anybody can do that. We're not doing that. We're doing this off the top of our head. So I'm also saying, hey, if you don't know something, don't hop off to the side and do some long multiplication to get there. I want us to see what we can get down on our own just based on memorization, on some recall. Okay, so right now, just to make sure that we're on the right track, I want you to write down the next 2 perfect squares in that sequence. Okay, we should be able to check and see then if we match up. So hopefully the next 2 perfect squares you would have would be 16 and 25. You see that the first red square was 1 times 1. The second perfect square in red was 2 times 2. Then we go to our 3 times 3. And so the next one in the sequence would be 4 times 4. So I know what 4 squared is 16. My next one is 5 squared. We've already covered that. 25. That gives you something to check against. So now what I want you to do is you're going to pause this video and write out as many perfect squares as you know off the top of your head. Okay, pause it now. Okay, we're back. So let's use this as a little bit of a gauge for us to see where we're at. Okay, I need my 6 squared, my 7 squared. We can keep going. My 8 squared gets me up to 64. My 9 squared gets us up to 81. My 10 squared gets us up to 100. And I would hope that we would have that cold. So I'm going to be a little honest with you here. Well, no, I'm going to be honest with you. I would be a little concerned if we couldn't get that gold list of perfect squares. We should have our times tables known, up to 10 times table. We should be able to knock out those gold. In fact, I think we should be good to be able to get to 11 squared, 121, and 12 squared, 144. And I think if you have everything up to the end of that gold line, you've got what you need. So if you've got that, feel very comfortable with where you're at. However, I am going to have a bunch of people that have some extra. So let's see how far we can go with this. Perhaps you know what 13 squared is, and you were able to get down 169. Maybe you have what 14 squared is, 196. Okay, I want to show you at least something that can help you out a little bit as we start to get into our bigger squares. Let's say that I jump to my next one and I said, okay, now I got 15 squared. Okay, I think 15 squared is like 230, I think. Okay, there should be a way that we know that that is absolutely wrong. And I want to go back and look at the previous. Look at all of your gold perfect squares, because that's your key. If you know everything up to that 10, look at the last digit in all your perfect squares. 11 squared ends with a 1. So what's 1 times 1, or what's 1 squared? 1. It finishes with that last same digit. 12 squared? Well, 2 squared finishes with a 4. 13 squared? Well, if I square the 3, I know I have to finish with a 9. 14 squared? Well, if I square the 4, that finishes with a 16, so that's why my answer finishes with a 6. So when I calculate 15 squared, I know that that green is incorrect because 5 squared is 25. That means I know my answer has to finish with a 5. And maybe we're able to then work our way back and go, shoot, no, it shouldn't have been 230. That should have been 25. So, something to keep in mind. If we continue on that path, then we're trying to come up with what 16 squared is. And I'm going to argue everybody should be at least able to tell me what the ones digit is. If I square my 6, I get 36. That ends with a 6, so I know it's got to finish with a 6. And if I allowed you to do some long multiplication, you would at least have a check. But maybe we're able to work our way in and say, okay, I just knew that it was 256. I think we're doing great if we get to that point. I think we're doing really well if we get to the 15 squared. So again, we just keep it going and we see how well we can do. Okay, we're jumping up to 17 squared. So when I have my 17 squared, now 7 times 7 is 49, so I know my answer has to end with a 9. Maybe some of us knew that it was 289. We then get to our 18 squared, and everybody should at least be able to get the ones digit down. Well, 8 times 8 times 8 is a 64. So I know my answer has to end with a 4. And maybe we get down to our 324. I'm running out a little bit of room here, so I'm going down to the next row. I need to get my 19 squared. Well, 9 times 9 is 81, so I know that my answer has to end with a 1. Nice. Well, what's 19 times 19 then? I definitely think we're getting to the end of a row for a lot of us. Maybe we were able to get to 361. But the weird part is I would have a bunch of people that couldn't fill in 16, 17, 18, 19 squared, but you could tell me what 20 squared was. And that gets us up to our 400. We're going to stop there, and I am going to tell you that if you know your perfect squares up to 20 squared, I don't think there's anything that's going to get your way with mental math. You have more than what you need in that context. So hopefully we're good with that process. You have that on your whiteboard. You have it in your notes. I'm telling you, make sure you know up to the end of the gold. If you know the green, that's bonus. Okay, I want to jump in and deal with some calculations now. So let's kind of go to the next section. Okay, what you see on the screen right now, we have our instruction again to simplify. You have 4 problems on the screen. I do not think that any of these should be a problem for you. So what's the whole reason we're going through them? I want to address a little bit of strategy, but for the most part, notation. Okay, first off, we are now simplifying an expression. Let's make sure that we've got some good form in our solutions. So everybody, we can calculate 8 squared. We've memorized that. We know it's 64. Make sure you have an equal sign at the front of that line. There's your communication. 8 squared is equal to 64. Don't just write down 64. It's bad form. Okay, we should all be good on B. We just talked about what 12 squared was. So we all know that 12 squared is 144. We are saying that expression equals that. Perfect. Okay, now we get to question C. And this is where I want to talk strategy. I would expect every single person in our class to be able to simplify what 2/5 squared was. So it's not about getting the correct expression, it's about how. If you said, okay, wait a second, I know a squared means multiply by itself. So that's 2/5 times 2/5. And we turn that into a multiplication of fractions question where we multiply straight across. I am going to put a huge boo across your page. Don't do that. Now, is the green correct? Yes. And is it important that we know the green? Yes. However, our best route through here is if we recognize that, then look at what that says. Let's go back up to the white expression. It says that 2/5 is squared. 2/5 is one fraction. It is all squared. So I need to square all parts of that fraction. That what I'm calculating is a 2 squared over a 5 squared. You're just never going to write that orange down. But you can see why the orange is true given the green. How about we just simplify it? So calculate each one of those values. Square the top, square the bottom, and you go from the original expression right down to your final solution. Okay, let's make, when we have a fraction all raised to an exponent, applying the exponent to the base, our primary method. Okay, now you take a look at D, and everybody should be fine on D. Okay, what I would like you to do is to pause the video and go through and get a solution to D. Okay, pause it now. Okay, we're back. So I am really hoping that nobody just put the blinders on and said, okay, so I square my. No, we have to be careful. Remember that 3 2/3 is really this. And because it's that case, I have 2 terms in my base. That means I can't just put my 2 to all parts of it. I would be breaking BEDMAS. BEDMAS would say add together those bases first before squaring. So I can't do that. Okay. I hope everybody's problem-solving skills kicked in, and you said, well, if I change D and try to make it look like C, then I can do the same thing. So everybody should have taken D, 3 times 3 and add on the 2 is 11, and changed D into an improper fraction first. Now D looks just like C. I have 1 fraction in my base. I can apply my squared to both. The other reason that you go like, well, why can I do it into the blue fraction and not my original? Well, if we were fuzzy at all on that, keep in mind that all that blue expression is a BEDMAS question. And order of operations says, if all I have is an exponent, which is repeated multiplication, so multiply, and division, I get to pick what order I want to do. So I'll deal with the repeated multiplication first. I'll apply my exponent. We get down to a pretty fast answer of 11 squared over 3 squared, and we're pretty good. So I would love to see the blue as your solution to D. Okay, so now let's change gears a bit. Okay, what you see on your screen now is we're going to take the opposite approach of the way we started today. So I'd like you to get down your little heading that we're going to change gears and we're going to talk about square roots. And then I want you to get down a definition for what a square root is. So I want you to jot down what you have, or sorry, what you see in red. If I was to define square roots, then I may say that it's a number, when squared, results in the given product. Now, I know that in a lot of cases, like we don't think of a square root that way, but that is a very technical definition. A number, when squared, results in the given product. Okay, that might not be overly clear for everybody, so let's answer the green question. Therefore, the square roots of 64 are. So I want you to go ahead and jot down your answer to the green. Now, if I was to ask you guys what's the answer to the green question, I would have expected a lot of people to go 8. 8. 8's square root of 64, and I would agree with you. 8 is a number that, when squared, results in the given product. The result has to be 64. So 8, when squared, 8 squared is 64, checks out. Okay, what's my other square root? Now, I'm going to have some of you that kind of sit there and go like, wait a second, there's another number that multiplies by itself to give 64? And we might be puzzled by the question. Some of us even caught that because in the green question, I put an S on the end of roots. So I told you that they were plural. In fact, I also told you that they were plural because I said R. So what's my other number that, when squared, results in 64? For some of us, we might think of this as a trick question, and by no means is it a trick question. But I hope that we also recognize that -8 would also do that. So if you are finding the square root to a problem, be careful. We could have two roots. Okay, what I want to do is I want to jump in now and just start dealing with some square root operations. This can get a little ugly as we go, so I'm going to ask everybody to kind of be patient with where we go. To the point where it might almost seem like we're contradicting ourselves, or I'm contradicting myself. We got to pay very close attention to the details as we move forward. Okay, next section. Okay, I would argue to you, leave a couple lines below each one of these problems. So when you get this down in your notes, just make sure that you have a couple lines of extra space to jot down our solutions or make any quick notes. Okay, question 2 asks us to find the square roots of, you see your colon, and then there are the 4 problems I want us to go through. Again, for some of this, it's not because I think you need it in terms of calculating. Some of it's going to be about form. Some of it's going to be about expectation. Okay, so let's take a look at A. Find the square roots of 81. So what number, when squared, gives us 81? I hope that we would all be good with 9. Now we also keep, but wait a second, it could also be -9. And I'm just going to tell you, we can write that in a better form. Notice how I duplicated my 9? Mathematicians are lazy. We call it efficient. We want to be able to write down stuff in good form. So the way we would actually represent that is plus or minus 9. I want to see the green. Okay, I think everybody could give me an answer to B very quickly. When we do that, a number that's squared gives me 100. Well, that would be 10. We also recognize -10 would do that because -10 times -10 gives me a positive 100. But we're not going to write it that way. Instead, you wrote down on your page plus or minus 10. Okay, now let's come to 90. Question C. I'm going to have students coming at this one from different perspectives. And based on their experience, they may look at that and their response might immediately be like, can't do it. And if I was to say, well, let's pull out a calculator a little bit and let's try to calculate that, you could do that right now if you wanted to. But I hope that we can see we're going to get an ugly value. Like, we're not going to get a nice, neat number to this. The square root of 90 will not be an integer. But could we estimate it? I would hope that everybody would at least be able to tell me that the whole number portion of the solution to that would at least be like 9 point something. Like that is, we can tell it's 9 point, we just don't know what the decimal places are. Okay, how can we tell it's 9 point something? Well, take a look at the two previous problems. You know that 81 gave you a square root of 9. 81 is a little bit below 90. 100 gave us a square root of 10. 100 is a little above 90. So 90 is in between 81 and 100. So the square root of 90 has to be between 9 and 10. So 9 point something. Okay, we're also not going to fall trap for the plus or minus. We recognize we need to have that. So what would I ask you guys to do? Well, without using a calculator, I think this is a great answer. And I know that that looks really weird, but seriously, like write down plus or minus 9 point something. From an estimation standpoint, that's probably very useful. How much the point something is probably is not going to have that big of an impact yet. The other answer I would accept is a plus or minus 9 and a bit. I know that probably even looks weirder. I love the phrase and a bit. You'll notice that I've already been using that frame a bit when we talk about fractions and decimals. They just represent bits of wholes. So I would love either of those gold answers. Okay, now I want us to tackle D. I think D should be pretty automatic for us, even though that might stump some of you guys at the beginning. You go, oh, it's a fraction. And I'm going to argue to you, well, if you were fine with the way we finished the previous section, we should be okay to finish this section the same way. Okay, what are the square roots of 9/64? Well, I'm looking for a value that I can write as something squared that gives me 9/64. Okay, I have a fraction as my answer, so it's probably pretty fair that I could maybe see that I might have a fraction now. Well, if we recognize that the way that we would calculate the square is to apply the square to both the top and the bottom, then what we want to do now is take the square root of the top and the bottom. We need to go backwards. And so I'm going to get rid of that red and blue, and we can simply calculate both. Okay, here we go. We know our answer is a plus or a minus. We could have 2. Take the square root of the top, so what number multiplies by itself to give me 9? What number multiplies by itself to give me 64? You come in on plus or minus 3/8, and we are doing great. Okay, there is us finding some square roots. Let's jump into the next section now. Okay, you'll notice that our instruction changed at the top of the board, and we are moving away from calculate and instead, from simplify, and instead I've asked you to calculate right now. You'll also notice that I've put in the formal sign for square root. Now, everybody should be good to remember what a square root symbol looks like, but just keep in mind, there's your little reminder. You would have dealt with it last year. There is our square root operation. Okay, so you work your way through calculating question A. What is the square root of 49 plus the square root of 16? Then in question B, I want you to calculate the square root of 64 plus 36. Okay, we're going to pause the video, do both of that, and we'll come back and check out in the end. Okay, pause it now. Okay, we're back. So I think we should have been okay with one hiccup. Everybody should have been good to make the calculations on both. Square root of 49, what number squared gives me 49? 7. The square root of 16, what number squared gives me 16? 4. The only hiccup may have been that we would have wanted to do this. And here's where I need you to know that that green is incorrect. But as soon as I say it's incorrect, I'm going to have some people that come back and say, Gray, you're contradicting yourself. You told me before that when I find the square root of something, I have two possible answers. And this is why I repeated it and said, listen very carefully. I want you to notice that nowhere in that instruction did it tell me, hey, Gray, find the square roots. No, it didn't. It said calculate. And when it said calculate, then I do the operations in the expression. When I choose to take the square root, I could have two possible answers, a plus or a minus. But when the expression has an operation of square root in it, it already tells you the sign. Hey, do you see a sign out in front of root 49? Nope. Okay, well, if you don't see a sign, what sign do we know is there? It's a positive. So that's why my 7 is positive. But we also notice in the second square root, root 16, it tells you what operation to put in between there. So because the square root operation was already in the expression, I don't get two answers for it. I use the sign of the root. So my answer to this question would be 11. If I very quickly threw up root 49 minus root 16, well, now my solution would be 7 minus 4. The sign out in front dictates what operation you do. Okay, I'm hoping that got us through A. We felt pretty good with it. Let's take a look at question B. I could see us coming up with two different answers for B. However, those two different answers, when we go through that process, are probably going to lead us to different answers, not the same solution. But I would argue that we probably feel more confident with one of those solutions than the other. Like I would say to you that when you take a look at B, this solution should have been pretty automatic. Okay, I've got this big square root, and underneath that big square root, I calculate. 64 plus 36 is 100. And now I have to calculate the square root of 100. What number squared gives me 100? 10. We don't have to address the plus or minus. We already took care of that in the previous problem. However, I would have some people that may have had this on their page. Hey, wait a second. I'm going to take the square root of 64, and then I'm going to add it to the square root of 36. Square root of 64 is 8. Square root of 36 is 6. And I get 14. And I'm going to ask you, between those two solutions, which one would you bet your life on? Like, I would hope that we were all good, that the gold is a correct solution. We maybe just tried the blue with kind of one of those thoughts of, hey, I'm not sure if I can do this, but I'm going to give it a shot. Now it's important for us to see why we can't deal with that blue. A couple things. Look back at the original expression. Remember, math people are lazy. And because math people are lazy, we tend not to write symbols down. If they're not needed, we don't write them. And this is one of those instances where they're not needed. That big square root symbol that you see that now has multiple terms underneath it actually means that there's brackets underneath that root. Mathematicians are lazy. We all say, hey, we don't need those. We can see the big root. That means do the operations underneath the root first. So let's just not write in the brackets. I hope that you can see that we would have broke BEDMAS if we chose to take the square root before adding. Okay, the other thing to recognize then, where did you guys first learn about square roots? Like, I'm going to bet for a lot of us, our experience with square roots maybe became from dealing with a shape like that in grade 8. You guys would have had a problem in grade 8 that would have said, hey, this side length is 3, this side length is 4. Find this side length. And I'll just call it like an X, a question mark. Well, maybe you guys remember how to solve that now. Maybe you totally forget. Don't worry about it. But I would have a bunch of people that are like, oh, wait a second. C squared equals A squared plus B squared. Yeah, I have Pythagorean theorem. And I'm going to bet that for most of you, Pythagorean theorem was the first time that you were introduced to a square root. Because it was needed. What did you do? Well, you said, my C squared is my X. It's my longest side. So I have C squared equals A squared plus B squared. I know that my A and my B are my two shorter sides, so there's a 3 squared plus 4 squared. You would have calculated both of those and said like 9 plus 16. You then would have taken that addition and said 25. And then you would have had to solve that equation. And using some opposite operations, what is the opposite of squaring? It's taking the square root. And so you calculated the square root of 25. You would then say, hey, square root of 25, that's 5, and you found that other side length. I'm hoping that that sounds familiar to you. Well, I just want you to notice, if Pythagorean theorem is the hypotenuse squared is equal to the sum of the squares of the other two sides, or, as you might think of it, C squared equals A squared plus B squared, why would we use any of that? Look at the first green line. If C squared equals A squared plus B squared, then can't I get rid of this squared by taking the square root of the other side? So can I get rid of this squared by taking the square root of the other side? Can I get rid of this squared by taking the square? And look at that line that I just put down. Doesn't that look like our original expression? The square root of 9 plus 16. The square root of something plus something. Well, we're all good that you calculate the 9 plus the 16, get 25, and take the root. But if I did what you tried to do in the blue, you're going to tell me that C is just 3 plus 4. C's 7. And if C was 7, then why don't we use Pythagorean theorem as just C equals A plus B? You guys are going to be like, because it can. It's not. Exactly. So I want you to keep in mind that there is a hidden set of brackets anytime we have multiple terms underneath that root that mean we have to do the operation under the root first. Okay, as long as we don't fall trap to either of those, then I think we should be good. Let's keep moving along in this section, okay? What you see now are 3 problems up on the screen, and I want you to tackle every one of them on your own. Okay? So let's go through, copy down those questions. Then you're going to pause it. You're going to get full solutions for each, and we're going to come back and see if we match up. Okay? Pause it now. Okay, we're back. So I am hoping that everybody sees that question C is just like B. This was one for us to get a little bit of a gauge to see how well are we doing with some stuff. We add together those two values and get 169. Now, square root of 169. So what number squared is 169? That's 13 squared. There we go. Hopefully not too bad. We matched up. We're good. I need to see both blue lines. Okay, now it comes to D. And D would have looked pretty ugly to some of you guys. Like now I take a look at D and I have square roots inside square roots. Okay, this is just a BEDMAS question, remember. So I take my time. If I have hidden brackets, then I hope that we can see that I have to work on the very inside first. Well, I can't add a 4 plus a root 25, but I can calculate a root 25. So my first line, I can't touch the 4. But when I calculate root 25, well, the square root of 25 is 5. Now I just turn D into looking like 1 like C. Okay, now I can go ahead and I can collect. And the square root of 9 is 3. I would need to see all blue lines in question D. Okay, you guys now tackle E. E might have been a bit of a stumper. I'm going to ask everybody, regardless of whether you get this question correct, as in our answer matches up, I want you to get this line down. I think it's going to help you going forward. When I asked you the question earlier about find the square roots of a fraction, that's really what I'm asking you in E. I've just put the operation in there. So I would want to see everybody's first line of that. Now, I need to be very clear, and I should have done this in a different color. This does not have to be a line in your solution. So that's why I'm putting it in green. But I want it in your notes. So if you got that next line in there, like just sneak in a little arrow and write, right? Like we'll jam that into our solution. But I want you to make sure that you can get that into your solution. Because now you see that really we're just calculating two roots. The root of the top and the root of the bottom. We should match up and we should be good. So in terms of the solution that you need to show me, you can go straight from the original expression right down to 4/5. But for your notes today, let's put in that middle line. I think it's going to help us out. Okay, we're going to stay in this section. We're still calculating. Okay, I'd like you to take a look now at F. Don't worry about copying down the rest. All I want you to do is get an answer for F. That is it. Then we'll talk about G, H, and I afterwards. So copy down F. I want you to get an answer. Then we'll come back and see if we match up. Okay, pause it now. Okay, so we're back. Here's my challenge to you in F. That I would actually hope that you got an answer to F without the number 3 ever coming into your mind. Now, I would bet for a large majority of us, like large majority, like 95% of us, 3 came into our head. And I don't think that's a bad thing right now. Like that is, we take a look at that and we say, okay, so the square root of 9 is 3. Now I have to square it. 3 squared, 9. Okay, but remember what I just asked you. I would want you to answer this problem without 3 ever coming into your mind. Here's the key. Remember that a squared is the square root, is the opposite operation of a square root. So those operations cancel out. It's the same thing as if I gave you this. -7 times 1,896 divided by 1,896. And I asked you, simplify that. And if I have anybody that is spending any time calculating, well, gee, what's -7 times 1,896? I'm going to say, hold on, what are you doing? Multiply by 1,896 is the same as divide by 1,008. Those are opposite operations. My answer is -7. I'm done. That what we actually have in question F is the same thing. Those two operations cancel each other out, and so we should be good to go directly to, oh, okay, equals 9. We're done. Now, you may have looked at it and you may have been going, I don't understand what his problem is. Like, why is he giving me grief over that? Like, I still got to the same thing. And now I ask you to take a look at question G. So what I would like you to do is get an answer to G, and I just want you to notice, if you were doing the same thing as F, well, what is the root of 5? Like, we should all be good that if you had to calculate what G was, well, the square root of 5, I don't know, that's like 2 and a bit. right? Like 5's between 4 and 9. 4's 2 squared, 9's 3 squared, so I'm 2 and a bit. And now you're trying to calculate what 2 and a bit squared is? Good luck. That we should be good to say, hey, wait a second. Square root squared, opposite operations. That's 5. Done. Okay, I'd like you to now copy down H and I, and I want you to get a solution to both. Okay, pause it now. Okay, we're back. So, on first glance on question H, I would have had a bunch of people that maybe said like, well, okay, so I understand from one of the previous ones that like I could calculate the square root of 72 and the square root of 50. Like my problem is that I can't calculate those. I can only estimate them. So like 72, that would have to be like an 8 point something. So 8 and a bit, because it's between 64 and 81, and that's 8 and 9. And then you do the same thing on the bottom, and we'd recognize that, well, the square root of 49 was 7, so we got to be like 7 and a bit. And I'm just writing that really sloppy. And then we try to go through and, okay, well, like, is that my answer? And I'm going to tell you, no, that is not your answer, to the fact that I want to get rid of it. That I would hope that any time we have to simplify something or calculate something, we also look to simplify it. And maybe it was screaming at you that, hey, that fraction that I have underneath my root, it's not reduced. That both of those numbers are even, and if I divided the top and the bottom both by 2, I can reduce my fraction to 36 over 25, and I love having 36 over 25 because 36 is a perfect square, 25 is a perfect square, and so when I calculate my square root of 36, square root of 25, and we get down to an exact value of 6/5. Okay, so if that wasn't our instinct, I'm hoping that going through H puts that into the back of our mind, something that we can start to gear towards. Always take a look and see if we can reduce a fraction first. Okay, question I should have been a little puzzling. I'm hoping it was puzzling. I'm going to just shrink down the screen a little bit so that we have a little more room to talk about I. Because I would have expected at least to have a decent chunk of students kind of say like, hey, well, we dealt with 90 before. That was like 9 and a bit. Oh, so my answer would be like -9 and a bit because, well, it's a -90. No. And I hope that we recognize that there is a major problem with I. Major problem. Remember what a square root says. It's a number multiplied by itself that gives that result. So I'm going to ask you, what number that's multiplied by itself, so squared, could ever give you -90? Now, if the 90 is still causing you a problem, what number squared could ever give you negative anything? Okay, let's come back to one key concept. Every time you take a real number, I don't know, 5, and you square it, well, you get 25. Well, if we take -5 and we square it, we get 25. Because when I'm squaring something, I'm multiplying it by itself, and that means that I have a matching negative that will always make my answer positive. So every time I square something, I get a positive value. How could I ever square something and get a negative? You can't. Okay, so what do we write then? And I'll fully admit that that seems like a bit of a trick question. And in our context, it was a bit of a trick question. Just make sure that we don't write like, oh, so you can't do it. And I would almost bet that I would have like some people who would want to write that. Like, no, can't do it. Not possible. There's actually a word answer to this. And in essence, it kind of means you can't do it. We never write can't do it, But our answer in this context is the word undefined. That if I ever ask you to calculate the square root of a negative number, you can't do it, but your answer, your description to that problem is undefined. Your answer cannot be defined. I can't tell you what the value of the square root of negative 90 is with real numbers. Like, I can't. So my statement undefined tells your reader you can't narrow it down to an answer. Okay, nice. Let's deal with our last problem. Question 4 is our last section for today. And here's where we may come across a little bit with an inconsistency, or at least in your mind, or a contradiction. I'm going to ask you to actually copy down all 3 questions right now. But in your notes, let's leave like 3 lines underneath each one. Okay, we're going to jump into A once you have all those copied. Pause it if you need to. But let's address question A. Question 4 has now changed our instruction and we've been asked to solve. So solve means I need to find the missing value, and I can locate the missing value in question A. It's x. So question A says something squared gives me 169. What is that something? Okay, I would expect, or I should say, you can give me a 1-line answer if you wish. I would totally take 1 line. So if you gave me x equals 13, I think you're close. Now, I would expect an awful lot of you to have x equals 13 written on your page. Here's the rub. Your answer is plus or minus 13. Now I'm going to have some of you guys go like, oh, wait a second. Now we're back to the plus or minus. Like, geez, I can't keep this straight. When do I have a plus or minus? When do I not have a plus or minus? And it all stems from the next line. That there's actually a first line in this solution. And I'd like everybody to sneak it in there. That what that problem says is some number, x squared, gives me 169. And you say, well, how do I get the x all by itself? Well, I've got to get rid of my squared. Well, how do I get rid of a squared? I take a square root. And listen to what I just said. I take a square root. So I chose to find the square root of 169. And when I choose to find the square root, then I could have a plus or a minus. Notice nowhere in your original question, nowhere up there was the square root operation written. But you're choosing to do the square root operation in your head. So we have to remember, we get 2 possible answers for that. Okay, let's go through fast on B. X squared equals 49. You have to solve for x. So you know x equals, well, something squared gives me 149. So I want to take the square root of 149. When I want to take the square root, I get a plus or minus. What number squared gives me 49? 7, and we're good. Okay, we come in with a question C, and question C should have been pretty automatic. So I want you to pause the video now, see what you can come up with. Okay, we're back. So question C kind of throws a bunch of stuff in together. I would hope we'd say the exact same thing. I'm solving for x equals, I got to get rid of my squared, so I take the square root. Square root I chose to do gives me, I have 2 answers, plus or minus. But when I go to calculate the square root of 20, I can't get that, not exactly. So I'm going to expect you to estimate that to a plus or minus. And now that I'm estimating that, well, geez, the square root of 20, well, 4 squared is 16 and 5 squared is 25. So I'm in between that. So I am 4 and a bit. Now, for me to get everything perfect in that last solution, I should also have a dot above that equal sign to show that I rounded to get to my final answer. Okay, we covered a lot of stuff today when only really dealing with two operations, squares and square roots. As I said at the very beginning today, I'm hoping that all of this was review. However, I'm going to bet that we added in some extra things to consider on squares, and we really expanded our understanding of square roots. Okay, your job, jump in, get some practice, and make this stuff automatic. Okay, best of luck.